Good morning, everyone. We'll start in just a few minutes. Let's give some the folks to the time to join. Good morning to folks who are just joining. We will begin in a minute, just to let everyone the opportunity to connect and join. All right, I think we have a good number. Hi, everyone from my side. My name is Dan Markin. I'm a developer advocate, and today I'll be talking about speeding up your CI/CD pipelines. We have just about an hour, so there's going to be some slides. There's going to be some code samples, definitely some code samples, and also plenty of opportunity for you to ask any questions. As I mentioned, I'm a developer advocate at CircleCI, so I help out developers wherever they are, build their software, hopefully better, faster, and more efficiently. If you want to reach out, I'm pretty active on Twitter, or just email me at zan@circleci.com. So yeah, quick agenda today. So yeah, we'll be just talking about who this webinar is for, what kind of folks could benefit from the content, a little bit about why CI/CD and pipeline speed is important and why we should be talking about it. And then we'll be digging into more practical tips and tricks. First, how to measure CI/CD pipeline performance using CircleCI insights mostly, but also looking at some integrations that can help you with that. And then once we have this idea of how to measure something, we know where the bottlenecks are. We'll be talking about how to optimize our CI/CD pipelines in practice, with an E, not an A typo here. Yeah, so we'll be talking about various things, various techniques. And yes, if you have any questions, any comments, my colleague Jess is with me at this webinar today, and she'll be helping moderate the Q&A. And yes, if you don't see anything on the screen, if I need to zoom in a little bit, if I need to go a bit slower, please do let us know. Either use the chat or Q&A. We're monitoring both. So that's it. So without further ado, let's begin. So the intended audience for this webinar. Oh, there was already one question. Yes, we will share the recording. I think it's going to be automatically shared shortly after we we finish. So yes, we will share the recording, and I will also share the slides separately, and I'll add all the links and all the resources that we'll be showing. I'll add them to the slides at the end, so you'll have everything. So yeah, intended audience, because it's more of an intermediate webinar. We expect some familiarity, some experience with CICD, and ideally also CircleCI. So if you're a CircleCI user, then you'll have like really actionable tips for how to improve the speed of your pipelines. And you could be role-wise, you could be a software developer working in DevOps. You might be a QA engineer. There's going to be something for everyone, but also for people who are working in ops, managing teams, and managing products as well. This is really something for everyone, but predominantly developers and people who write tests and manage DevOps pipelines. Anyway, why do we care about speed in CI/CD context, especially? First, every organization deals with software in some way. It's just going to be more and more prominent in the following years. And so because of that, software delivery is something that impacts the entire organization, the entire business, regardless of, yes, whether you're working predominantly in tech, or tech is something that you use to power your business in some other way. There's always some software delivery involved, and the faster, the more efficiently you can do it, the better. With software in particular, when we're thinking about where CI/CD kind of lives, so it's right there in the middle between code being written and code being run in production. And I'm sure you all know what CI/CD does. Essentially, this is this intermediary step where we do automatic builds of software based on the source code that we commit. We run a lot of tests automatically, of course, and also we deploy that new built and tested software to where you want to run it. So whether that's your Kubernetes cluster on any cloud, whether it's a mobile application, a web application, it doesn't really matter. All software starts with some source code where we collaborate, and all software is then operated somewhere else. And in the middle, you have this CI/CD pipeline, which kind of helps go from left to the right. So yeah, and because of that, speed matters a lot. First off, it's the faster we can execute pipelines, the faster we can ship things. So, and also because our pipelines also will test software for us and verify it, it will also shorten the feedback loop for developers, whether it's just committing some changes on a branch or whether you're actually waiting to merge a pull request, for example. You will shorten that feedback loop because developers won't have to wait for that CI/CD pipeline to finish before they can actually continue on the next ticket or continue deploying your software. So this will, on a team level, on a product level, increase your velocity for shipping software. You'll be able to ship smaller pieces of change faster, more frequently, and ultimately, yes, ship features faster, ship products faster. Developers won't be bogged down by slow processes, which is always good. And ultimately, as every organization is a software organization, you will be improving organizational agility and, yes, the ability to essentially action change in your industry. And yeah, so that's basically some motivation of why we should be always looking at pipeline speed in our case. And I've mentioned CircleCI, but if in any case you don't know us, we are the leading CICD platform, and we've been around for a number of years, just over 10 years now. And we help teams everywhere build better software faster, more efficiently, with higher quality. And yeah, all our customers will usually vouch for us, and yeah, whatever you're building, however you're building, we can probably help you do that faster. And yeah, so that's a little bit about motivation, a little bit about CircleCI. Now let's look at some tech stuff. So today we'll be looking at examples which contain both our configuration files and our the dashboard. So the CircleCI's UI. So if you're thinking about how a pipeline is configured, it's all done through code, which lives within the same repository that your code lives. For example, I have one of my demo projects here. If I need to zoom into anything, please let me know. I will do so. I have this directory in here at the top level called .circleci, where you have this config.yaml file where everything is configured. So pretty much all projects are configured in that way within your repository. So it's tied to the same commit. And yeah, so that's our config file. And on the other hand, we have our dashboard, which allows you to essentially browse all the pipelines that you have going on in all the projects. And there's also insights, settings, and so on that are relevant for you. I'll be going deeper into that a bit later when we're talking about specific features. But for now, yes, these are the components that we're talking about. Speaking of config, the top level item that we're configuring in this YAML file is a pipelines, which is also what gets triggered whenever you create a new commit, or there's other ways to trigger as well. We'll talk about that later. Each pipeline contains one or more workflows, and a workflow is essentially a collection of jobs that execute in a given order. This can be either sequentially or in parallel. And a job is like this single self-contained set of commands that execute in a particular environment. So either a Docker container, a virtual machine, and so on. And commands are just commands that you would run in that virtual machine. So yeah, this is just compute that's executed based on a configuration that we specify. Cool. So now that we've kind of covered very basics of what CircleCI does and how it all looks, and hopefully what we're going to be talking about, let's talk about measuring pipeline speed and performance. So first thing we want to ask ourselves is, what do we actually want to measure? So is it just execution speed of a single job? Or is it an execution time to execute an individual workflow? Or is it how many times we can actually run these workflows per hour, per day? So that's our throughput. They are different numbers. They tell us different things, but together they usually tell us a story about how quickly a team is able to build and deliver the software that they're working on. And the tool we'll use to measure all of that is called Insights, which is a feature of CircleCI. So in CircleCI, you have this Insights tab on the left-hand side, which is which lists you all the projects that you have in the organization. These are the recently run ones. And at a glance, you can see things like how successful they are, how quickly they or slowly they usually run. So for example, let's look at our demo full project, which 7 days. So yeah, and in here you see different workflow durations, how successful they are, how much, how many times we are able to ship it per day, for example, and digging into individual workflows, for example, node, test, and deploy on my main branch will give us some ideas of our previous runs. For example, 19 hours ago, I had some errors, and then I had a successful build this morning, just an hour ago. And you see at a glance, like which jobs, which workflows are might be problematic, and which starts to give you an idea of where you might find some bottlenecks. And you can also navigate to this jobs tab here and see also which jobs take the longer. So we have a number of jobs. One is a build Docker, one is dependency vulnerabilities, and these are all build and test jobs. We'll go into them a bit later, but ultimately you can see also what they do. We are also able to figure out our test success rates. Now, these tests are they're more of a sample test, so they never really fail. But if we had like a real world scenario where we commit code and that gets tested automatically, you'd see different success rates and different numbers of tests, hopefully increasing here when you are building your software. Going down, you can dig into what are the slowest tests. Again, very valuable if you're a QA engineer, whether you're a developer, because you can actually go in and understand how long each test will run, how many times it's run, what the success rates, and this gives you a good idea of, yes, I can start optimizing these 5 tests, and this will give us this some notable improvement in our performance. But yeah, as I mentioned, these tests are very, very basic, very set up to just illustrate our what you could see on the platform. And yeah, this works for pretty much any project. So I have one of my nightly snapshots. This is an Android project, a bit bigger. It runs a bit more tests, and you can see that, yeah, they last for different times, and the duration changes and so on. So yeah, that's kind of where we are with insights, which allows you to kind of see where the bottlenecks are, where you might find some improvements. It'll also show whether a job has been timing out, because we do have a limit of how long you can run a job. So on the free plan, I believe that's by default for 1 hour. This goes up on various different plans, but you don't want your jobs to be running indefinitely. You want them to terminate, obviously, within some sensible time limits. And the last one is like time to recovery, which is more of a team metric. So if you commit something that fails the tests or fails a build, your build will obviously show as failing. So let's find one. So I had a error in the config. This is not a really good example, but if we had like some tests failing here, this would show as for example, this one as a failed, and then you could also analyze how quickly were we able to get this from failed back to successful build, which is another very useful metric. If you are interested in getting these insights elsewhere, there is an API as well. So there is an insights API where you can just query your pipelines, your jobs, your workflows, and get the same information out. And we also earlier this year introduced integrations with a couple of popular dashboard kind of or data companies. So Datadog and Sumo Logic, they integrate through webhooks into CircleCI. So you get CircleCI pipeline information in there. If your organization is already using them, you can actually get that information there into Sumo Logic and Datadog. There's docs for both, but yeah. And obviously you can build your own integrations if you have another type of tool. So yeah, that's about measuring speed. But most importantly, we need to think about what's good enough for our organization, because just how quickly something executes doesn't really matter, especially when it comes to tests. If you were cutting the tests to a degree that you're not really testing what's relevant. So it's always about balance when it comes to how quickly do we need something to execute and verify it, because yeah, the more you test, the longer it's going to run. And you want to find that balance for, yeah, what's this, how much of a signal you want to kind of carry across. So yeah, now we've hopefully helped to identify some bottlenecks, some areas where we can improve. And now let's look at how we could optimize our pipelines in practice. So first off, we can think about what resources are available for us. So we offer a number of options to execute your jobs in. So Docker images or Docker containers, virtual machines. We also offer things like GPUs and RAM disks, which can speed up your execution. Docker will usually spin up the fastest, just because it's very quickly to spin up containers. Virtual machines will always take a bit longer, but some payloads can't be executed on Docker containers, so you need virtual machines. And the same, like you need a virtual machine for software that needs to run on a Mac or a Windows, for example. And yes, obviously you need a virtual machine if you want to access some GPU resources as well, if you have these kind of heavy computation heavy workloads. And you have a lot of IO in your builds. You can also leverage RAM disks for that. So I think there is yeah, there's like a lot of this optimizations that are covered in the documentation. Yeah, so I think choosing executive type is a good relevant doc here. So yeah, with Docker, you can always use one of our own images as well. So they would begin with CIMG, called our convenience images, and they are they contain, actually, let me go to the CircleCI developer page. So our convenience images, they contain things that make sense for a given platform. For example, for Android, for Go, for MySQL, for Node.js, and they're regularly updated, ship with various versions. For example, Node.js, they ship with various versions of Node.js for each different image. So it's quite easy to pick just the one that you want. And there's also a base image, which just contains the most common utilities. So yeah, if you have just like a language payload, one of these is super useful. But also if you have something else, then obviously you can continue that. Then once we've kind of decided what we want, so whether we want to run something on a Docker container or a VM, we want to figure out what resource classes make sense for us. So resource classes are essentially how much RAM, how much CPU is available here. So so for example, you have this table here, available resource classes. So by default, I think it defaults to large. So 4 virtual CPUs and 8 gigs of RAM. And if you need more RAM, for example, if you're hitting out of memory errors, or if your payload, if your workload is quite complex or can leverage multi-threading, for example, some compilers, then you can go bigger, so X large, 2X large, which will give you more threads to use, and you'll be able to get more done faster. But obviously with resource classes, it's always good to just kind of see what works best for you, because yes, different languages, different compilers, they won't be able to use multi-threads. They won't be able to kind of leverage all the extra RAM. So find one that works best for you. And there's also things like compiler and execution flags that you can use. So every different tool framework that you might be using is obviously different. They will have different flags, and some of them are able to leverage multiple threads. Some of them are single threaded. So yeah, just kind of figure out whether there's something that can speed up your build using that kind of configuration that you can pass in to those commands that you're using. And yes, resource classes. Let's see if we have an example. I think I have a small one somewhere. I have a small one in here. Or maybe I don't. I thought I had a small one here. But yeah, we could do, for example, I hope you can see this. I'm showing some code here. Zoom in a little bit. Just gonna use resource class X large, for example. When you're configuring a job, for example, and that will run it on an X large resource class. So that's like resource classes where you want to execute something. Just think, can you do something on a Docker container? Great, that's going to spin up very quickly. Do you need a VM? How big you want it, and so on, and what kind of job workload you're running. After that, after we've chosen the resource classes, the executors that work for us best, we can think about running things in parallel. And there is a lot of things we can run in parallel in CircleCI. First, we can run multiple workflows and multiple jobs within a workflow. So each pipeline can contain multiple workflows, and they will by default all execute at the same time. So you can have, but to be honest, with workflows, you usually have like one test, build, deploy workflow, and then the others might be for nightly builds in my case. With jobs, you obviously specify a number of jobs in our workflow. So build and test, dependency vulnerability scan, build Docker, which by default will execute in parallel if you just specify them like this, unless you specify this requires, and then it will require this prior jobs to run. And this will give you something akin to this graph where you show, okay, these are all running in parallel concurrently. And once all of these have passed, then we can continue. So think about your kind of job workflow graph as what can run concurrently, should run concurrently, and only when you kind of reach a point where you want to like prevent something from happening. If your tests fail, for example, then you want to do a required step. So like build Docker and then deploy somewhere. So that's like pretty out of the box. It just requires one requires line. But then you have things like running in matrices as well. So a matrix, for example, is a way to pass parameters in CircleCI to a job that will create parallel jobs with one of those kind of combinations of parameters in these matrices. For example, I have a node version parameter that I'm passing to my build and test job, but I could have another parameter, for example, not just node version, but also you can have a browser type like Chrome, Firefox, a version of that browser passed in, and it will kind of create a matrix of all of these kind of parameter combinations and create you jobs based on that. So they would then run all in parallel. So my build and test jobs 14.2, 13.8, 15.11 are all created from this matrix. And really all you need to do that, all you need to set up is specify parameters in a job. So that's my node version. I can give it a default. You don't have to, but a job won't run if you don't pass in a default, if you don't have a default. And then the more parameters you have, the more you can pass in that matrix. And that'll just kind of explode into multiple jobs then, which is quite useful. And last one, that's probably the most important and the most relevant for most people when it comes to parallelism, is splitting the tests. So if you have any like functional tests, anything that touches UI or the whole integration, then you are likely to encounter like these kind of slownesses in your tests that just kind of like explode, because you're not running unit tests anymore. You're running unit tests that run like hundreds of tests in like 5 seconds. You're running tests that take some setup, that take some steps, that require something in the UI, for example, to change. So you're running tests that probably take, I don't know, 15, 20 seconds each. And they can easily grow to run for like 10, 20. The worst I saw was like 8 hours, I think, or 6 hours in an Android application in my experience. And if we had this kind of test splitting, we could essentially split this across multiple jobs. And to do that, what you really need to do is like you can see this in action. Like I have this run tests no split, which runs everything in a single job, which runs for 4 minutes, and I have I think I have like 100 something tests to run, and in here in my matrix, I have 4 concurrent jobs, which run for, one runs for 56 seconds, the other run for a bit over a minute, but ultimately a lot less than 4 minutes and something. So yeah, there's 101 tests in total for this. And to do that, you need to use the CircleCI CLI. And there is a command called CircleCI tests. So which will help you identify the tests based on any input argument that you pass. So for example, all the tests in this test directory that end with test.js, and use a glob expression for this. So wherever you have your tests, you can split them like this, and then pass it in, pipe it to the CircleCI test split, and which gives you a list of files to run. And then in Node.js example, we can just use xargs, which kind of takes all those all these kind of subsets of those tests and passes them to my npm run testci command as an argument. So we're looking at like a number of test files. So long running A, B, C, D. I've just created these to kind of show a number of files, and they're just got various numbers of delays to show how this can run for a longer time. This is very much not a real example, but a real example would still have test files that you can then split. And then when you have your job defined, you pass in a parallelism. So parallelism within a building test job will take 4 concurrent jobs instead of a single one. So that kind of shows you here. And you can have a lot. Like this is obviously on a performance plan, but by default, I think you have like 30 parallel runs on the free plan, which is pretty cool. And you can really kind of go super parallel very easily. And obviously, because we're running tests in different containers, we still need to kind of like merge the test results together so that we have these kind of tests data all together. But ultimately, you can do this with almost, or if not every test tool. There's going to be steps are going to be different for Python, for JavaScript, for Java, for Android, for iOS, but you should be able to do this and split your tests, and for really high gains in terms of test duration. So this is one of the most impactful, potentially most impactful things that you can do. There's a very relevant question just came in. So if you set parallelism to 4 for X large instance, there's still just one instance. No, parallelism for 4 for X large instance would spin up 4 X large concurrent jobs, which runs a subset of all the tests. So they're still larger instances, but they are running in they're running a subset of tests. Does that make sense? I hope it does. So it still takes the same resource classes. Cool. Right. So we've done parallelism, and now we can talk about caching. Caching is nothing other than deduplicating work. So something that you've already done, whether you've already installed some dependencies or pre-built something, you can cache that to use that in a subsequent operation. I like to split caching into two kind of logical parts. One is deduplicating the requirements, what you need to do the job. For example, this can be our package dependencies. So in our Node example, if you do npm package install, if you know Node, it will download all the dependencies, and these dependencies can be pretty significant in size, and this all needs to be downloaded from the web. By using a cache, you essentially analyze or like compare your package log file, which kind of contains exploded versions of all the dependencies, their SHAs, and all the sub dependencies as well, in order to kind of have this single frozen version of all the packages. And if that hasn't changed, it won't re-download anything. But if it has, it knows to re-download everything. So in order to utilize cache, let me find this here. Yeah, you can use this save and restore cache commands, which kind of come built into CircleCI, and they're essentially just commands that you can use in a job, and then you pass in what you want to cache and the name of the cache. That's usually some kind of hash of itself. Or if you're using an orb like I am here, like CircleCI node orb, caching comes pre-written for you, predefined for you whenever you're installing packages. So let's look at that orb and see how this is done in practice. So orbs are predefined, prepackaged sets of CircleCI config that you can use. They come with commands, they come with their own jobs, but we're interested in, for example, this install packages command, which is what we're using here from this orb. Look at the command source, and so yeah, you'll see that when the cache is turned on, by default it's turned on, it will use this restore cache, and then it creates this cache key essentially, which is kind of compared against. This is pretty advanced, so you usually don't have to write something as advanced as this, but it's based on a branch, it's based on a commit SHA, and so on and so on, and or actually the log file SHA. And you first check if there's a cache available. If it is, it will download stuff from CircleCI, so it doesn't have to go through the network. If the cache does not exist, then you save it at the end, and you usually do like a restore, install packages, and then save cache in that order, so that if the cache exists, you don't have to reinstall anything, because it already knows that it's got everything, and it then resaves the cache so it can be used in a subsequent build. Yeah, there was an earlier question about would it be possible to add AWS to CIMG images? We have to create our own images just to put AWS command in them. So that's another thing you can do. You can essentially use your own images instead of our own CIMG images. So they will help you if you have some kind of dependencies that you always need. You can just use your own Docker images, and that's going to spin up the containers that have everything that you need for your project. With regards to adding AWS to our own images, the best way to do that is essentially using an orb. So I'm going a bit off topic now, but there is a number of AWS orbs, and there is a number of GCP orbs, and that contain tools, and they will install the CLI in there. So, and I think if you use the orb, it will also cache any stuff or anything that you might have. I might be wrong, but in some cases you're able to use the orb to actually install something, cache that, and then reuse that later. But yeah, if you have something like that, I would say this is the best way to do it. If you need a very common dependency like AWS, for example. But yeah, I can definitely ask my team if they would consider adding AWS, but I believe the suggested approach is to use the orb. I hope this answered your question. And yeah, the other thing you can do is cache what you've already done. So work that you've done. So build artifacts or pre-built artifacts. So if I have a number of tests I want to run on an application that I've built in the previous step, you can actually store that either as an artifact or store that in something called a workspace, which is essentially allows you to pass things across different jobs. So workspace mounts a directory in that container that you have, and then you can save anything to it and then restore that workspace in the subsequent job. So you have exactly the same stuff. So that's another thing you can do. Yeah, so I hope this is all kind of makes sense. So persist to workspace, and that obviously will allow you to kind of pass anything. So if you've got like Gradle will create, for example, a lot of artifacts that you can then reuse later. But yeah, caching always breaks some isolation. That's always a trade-off that you're looking at. So if you have a cache, because you're not downloading the dependencies every single time, you're not downloading everything, doing everything in isolation. So some people don't like that, some people do. I would argue that caching does speed up things so much that it's worthwhile potentially breaking that isolation. Yeah, some tools, some package managers like Node, NPM, for example, it has an NPM CI command, which will always re-download all the packages, which obviously doesn't work with all that caching. So think about what you want. So you want to do the NPM install, or you want to do NPM CI, which will do everything on its own, but it will take longer. So figure out which works for you better. There was another comment actually from someone about the AWS in images. So just echo the question about AWS CLI. We use our own Docker images because your case will be unique. We use AWS CLI in some cases. It's a two-liner in Docker images, so it's not too bad where you can control versioning, etc. You'll probably need other dependencies anyway, so it's not that much hassle. So yeah, really depends on what you need. Thank you so much for this comment. It's super valuable to know what people are finding that works for them, because usually like there's so many possibilities here. So pipeline optimizations, that's the last thing, like caching and parallelism that's like built into CircleCI. It's like test splitting will work for any kind of test scenario, but this is very, very specific to any single project. So you really think about what work can be done in sequence, what work needs to be done every single time you do a commit, and what work needs to be done only when you are cutting a new release, only when you are on the main branch, only when something else happens. And for that, you can do workflow filtering, for example. So for example, I have my node test and deploy job. If I were on a main branch, this would always run everything. But if I'm not on the main branch, if I'm on a feature branch, for example, I don't want to be deploying this anywhere. So I don't want to be asking for approval, for example, of my colleagues to review something. I just want to run my tests. And for that, you can do a branch filter within a workflow. So a different job will not execute unless these filters are passing. You can do branch filters or tag filters as well. So if it's a new tag, which contains version, blah, 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 something, you can filter that way as well. And that will allow you to then select, okay, I want to run my unit tests every single time I commit, but I don't want to run my expensive integration functional tests that take a long time unless I'm in this particular scenario. But you can always schedule something like a nightly build, which will run all your tests, but they're not dependent on a commit. So scheduled pipelines, we just released this a few months ago. And for every single pipeline that you have, you can create a scheduled trigger, which will essentially, let's look at our demo full, which will trigger something like an hourly test, for example. This runs every single hour. And for that, you go into project settings on the right-hand side when you're looking at a project, and then use the triggers here. Then just add schedule trigger, give it a name, select days, select hours. So if it's a nightly, you're looking at around midnight probably, how many repeats you want per hour, any specific branches, tags that you want, and any pipeline parameters. And they will trigger every single time. So I've got one library, which is kind of pushing nightlies from the main branch to the snapshots repository on Maven Central, for example, or this can just run your functional tests whenever there is so they're outside of your kind of main commit push test flow. And yeah, if you want to have like different projects, yeah, so I've got my hourly tests here. So you can also pass like pipeline parameters in and then select on that based on which workflow you want to run. So my hourly tests only want to run when my pipeline parameter for run schedule is selected. And my node test and deploy, which is my main commit workflow, is not going to run whenever you want to run something on schedule. And yeah, to do this, you just kind of like specify a pipeline parameter. A type would be Boolean in my case, and what the default is. So this will make sure that I have a hourly or nightly build going on, which is quite valuable. And last thing you can do, or one of the other things you can do, is really configure something in a way advanced manner using something called dynamic workflows, for example, or dynamic configuration. So this is another project of mine, which is a multi-platform app. It builds an Android app and it builds an iOS application. And it will select which part it will build based on which path has changed. For example, if I've only worked on the Android part, it will only build the Android part. If I worked on the iOS part, it will only build the iOS part. So this can like speed up your time, speed up your builds, and also, as you can see, this one just ran Android and this one ran both. Yeah, this can like speed up your builds, speed up your things a lot. And in my case, in this project, this is just looking at the path. So my Android app path has changed, then it will toggle this build Android. The thing to know with dynamic configuration, it has this new stanza here, setup true, which indicates this is a setup workflow which executes first, and then you pass in a continue workflow. And you can actually just create that workflow configuration from these jobs as well. So you can essentially do anything. So it's very, very powerful. Yeah, in my case, I'm just setting my parameters, and then in my continue workflow, which executes afterwards, I'll just look at, yes, which Boolean parameters are toggled and run accordingly my workflows. So Android or iOS or both, obviously. So these are like some options for further pipeline optimizations. There's a ton more we could talk about. If you have any questions, I would love to answer them. Oh, there was one question regarding caching checksum. Can you pass a directory instead of separate files? That is a good question, and I am not 100% on this. I think that if you kind of zip the directory and manage to do a checksum on that, that could work potentially. I don't think it's able to take a single file by default, but you can always create one file out of more. I'm not sure if you can also do a SHA of a directory. If you could, then that would be also possible. But yeah, definitely something I might have to look into that. But I'm not 100% sure whether that's possible to cache a directory. Yeah, it's usually looking at file names, but I would probably zip it and then let's see. Or yeah, if you can, yeah, get a SHA out of a directory itself. So I hope this answers. Another question: is it possible to improve caching of custom Docker images? So yes, I think that's possible. If you're building Docker images, there is also this thing called Docker layer caching, which essentially allows you to cache. Come on. It's not finding anything. I'm hoping that So Docker layer caching will allow you to cache when you're building Docker images, each Docker layer, and it will use whatever is the most of your Docker file that's unchanged. So you only kind of built on that last thing. So if you've got like using this dependency and installing a couple of more things to the base image, and then running your final commands, you can. Why does this search not work? This is slightly annoying. Maybe I have a bug in my browser. I don't know. It's just JavaScript. But yes, there is this thing called Docker layer caching. Now, so yeah, this will you just enable it if you're building Docker images, and then you basically cache layers until they change. There's quite a lot of stuff in here, but yeah, hopefully this works for you. Can this advanced setup variant also be used with parallelism? So this is probably related to the dynamic workflows, the dynamic configuration that I showed you. Yes, like whatever you're setting up, like in a setup workflow, can be then like whatever you execute subsequently is just a normal config. So you can add parallelism, you can add desk splitting, you can add caching, and that will, like, it doesn't impact how other workflows or pipelines work. This is just making sure that you can run some work before you do the main work, and essentially modify your configuration based on that. Is there any nice way to wait for multiple jobs? Now we have a workflow with 2 test jobs, and with jobs that should do things and post to Slack if both pass, or just post to Slack if any fail. Which requires it's only possible to wait for both to pass, but we have a third job which just pulls the CircleCI API to be found if 2 jobs pass or fail. Yeah, I think that's the best way to do it if you need to wait for multiple jobs. You can also have a post step in a single job. So in a configuration, you can have I think it's post steps. Yeah, pre-steps and post steps, which will be added to your job. So you can add to both to evaluate the job and then kind of see trigger, so that you would trigger as soon as the first one triggers. You would trigger it as soon as the first one terminates, whether that's successfully or unsuccessfully, and then also see the second one. I hope this would work for you. But yeah, you can also be pulling the CircleCI API to find out if they pass or fail. There was another question. To summarize, best thing to do when checking how to optimize pipelines. Yes, definitely check insights. Yes. Parallelism and caching. I had to do them in some order. You can do them in other order as well. So yes, you can look into parallelism first and then look into caching, or you can look into caching first and then into parallelism. Really depends on what kind of workload you're doing. If you see that your tests are running for a long time, parallelism might be the best one to do. If you see that your build setup is running for a long time, maybe caching is the way to go to look into first. But yeah, like first step is definitely understanding what's going on, what you want to optimize before you try to like optimize something. Because if you don't have this understanding at first, you're not going to have you're not going to know where you should be making your optimizations. So yeah, this is kind of like all we had. If there's any more questions, please to ask now, or yeah, just reach out to me. My email is zan@circleci.com. And as I said, I will be adding all these links that I talked about, all these code samples in this presentation and share it with you afterwards. I don't think there's any more questions. Is there?
No, we're all good, Zan.
Awesome. Thank you so much for attending. I hope you found this valuable, and I hope you have a lovely day. Bye.